Okay, so for each of the problems that you sent me, I'm actually going to show you two different ways to do them. One will be doing it with the algebra, with some solutions and some insights, and the other way I'm actually going to show you how to do it using the TI Inspire. So that way on a graphing calculator you can actually see other ways to solve these. And again, online graphing calculators such as Desmos work really well for this too. So, which ordered pair is not in the solution set of 2x minus y is greater than 3? Well, all we have to do is substitute in our x and y values into 2x minus y and see if it is greater than 3. So again, let's just go ahead and start with just go ahead and point A. So again, I'm going to say is 2x minus y, is that greater than 3? So if x is 2 and y is 0, I'm going to get 2 times 2 minus 0. I wanted to know, is that greater than 3? Well, 2 minus 2, 2 times 2 is 4, minus 0 is 4, so is 4 greater than 3? Yes, it is. So A checks out. And again, remember, we're looking for the one that is not in the solution set, so we need to keep going. All right, so my next point here is going to be 2, 1. All right, so again, I'm going to say is 2x minus y, is that greater than 3? So again, I'm going to have 2 times 2 minus 1, is that greater than 3? Well, 2 times 2 is 4, 4 minus 1 is 3, and 3 is not greater than 3, it's equal to. So since 3 is not greater than 3, your answer here will be B. B is not in the solution set. Okay, so now let's go ahead and take a look how to do this inequality problem by graphing. And what we're going to do is, I've got the TI Inspire loaded up here. You can use really any graphing calculator you want, or even an online graphing calculator like Desmos. As long as you can graph inequalities and points, you're all set. So for the TI Inspire, we actually, by default, you get the function menu entry line, f1 of x equals. Well, we don't want to graph a function because we have an inequality. And so I don't even have a y equals because, again, I have a standard form. 2x minus y is greater than 3. So I'm just going to have to go down to relation, and I can just graph this as is. 2x minus y is greater than 3. And there it is. You'll notice we have a dotted line because it's just a greater than. And here is my inequality that's already shaded in. Now let's go ahead and graph the points. To graph a point, we use geometry, points and lines, point. The nice thing is I can actually just hit the left or open parenthesis key. You'll see that red key highlighted it to the left. And it's a little different to enter points in on the Inspire. So I hit the x coordinate, enter, y coordinate, enter. So if I want to graph the point 2, 0, 2, enter, 0, enter, there's the point 2, 0, and you can see that is in the solution set. It's in that shaded area, so it is part of my solution. And we already know what the answer is, but again, let's just go ahead and check the point 2, 1. You'll see the point 2, 1 is on the line. And if you're not sure about that, you can come up here to View. I can go to Menu, View, Grid, Lined Grid, and you can actually, with that grid, you can see it a little bit better, but you can see that the point 2, 1 is on the border, so it is not part of the solution. And we didn't check the other 2 1s algebraically, but let's just go ahead and do that. Here I'm going to use the Recent tab. It'll be Control Menu on your handheld calculator. I just have to right click on my software, so we'll choose point. It's a little bit faster to get it back there. And we're just going to go ahead and check the third and fourth answers. So I had 1, -3. Again, we can see that down here. That's in the solution set. Let me move that label out of the way. And we'll go back to recent and point. And then let's just go ahead and say we want 3, -1. Whoops. 3, enter, -1, enter. And again, there it is. So the only point that's not in there. Now, if I lose track of it, I can, again, highlight the point, Control Menu, or right-click, choose Coordinates and Equations, and then there's the coordinates of the point that is not part of the set, which is 2, 1. Okay, so moving on to the next one, here we have a triangle and we need to find the area. We have a base of 3a minus 1 and a height of a plus 1. So this really just starts out with what is the area of a triangle, and my formula for area of a triangle is 1/2 base times height. So I'll worry about the 1/2 at the very end because I just really have to divide everything by 2. So base times height is just going to be 3a minus 1 times a plus 1. So algebraically, this is just going to be 3a minus 1 times a plus 1. And I'm just going to go ahead and FOIL this. So first, 3a times a gives me 3a squared. Outside, 3a times 1 is just plus 3a. In FOIL inside, -1 times a is going to be minus a. Notice I'm stacking my like terms on top of each other. And then my last two is just -1 times +1, which is -1. And then I'll go ahead and add my terms up together. And I get 3a squared plus 2a minus 1. Don't forget I still have to apply this 1/2, which means I just have to put everything all over 2. Since 3 and 1 are, or minus 1, excuse me, are odd numbers, I'm not going to worry about dividing by 2. And also, plus, I can just look over here and see that my answer choice is going to be B, 3a squared plus 2a minus 1, all over 2. Okay, so there's a lot to unpack in this problem here. We've got a fractional exponent or a rational exponent. We have some variables that we have to cancel. We've got some simplification of numbers, and we also have some negative exponents. So let me see if I can kind of handle this step by step by step. So first thing is, we've got this 3/2 power that's going on outside. That's really not as complicated as it seems. A fractional power is a square root. So I'm going to kind of show you a little bit of what's going on about that over here. So for example, if I take x to the 1/2 power, that's just the square root of x. And we write that as the 1/2 power because then the laws of exponents apply. It's really hard to, it can be difficult to work with radicals or square root signs, but fractional powers or numerical powers are pretty easy. And obviously if I just have a 3, it's x cubed. So what that means, if I have x to the 3/2 power, what that really is that's the square root of x and then cubed. So that's all that's really going on. The other thing is that I can multiply it by 3 and divide by 2. And so in other words, when we get to higher powers of x or y and z, we'll see how that works. All right, so that's kind of what we'll deal with in the fractional exponent, and we'll talk about that last. But just keep in mind what that really means, the square root of x cubed. Okay, so the next thing is I have a couple negative exponents. Negative exponents just move to the other side of a fraction. So for example, if I have x to the -3 power, that would equal 1 over x cubed. It just goes down below into the denominator. Likewise, let's just say I have x to the, or let's just say I have 1 over x, and let me go ahead and erase this to give me a little bit more room here. All right, so let's just say I've got 1 over x to the -4th power. Well, that's just going to equal x to the 4th. So the negative moves it up top, so I go from denominator to numerator, and then the power stays the same as 4. So that's kind of everything that's going on. And the last thing we have to worry about is the 28 over 252. Well, if I look at all 4 of my answer choices, I don't see any number up top. And so that tells me that 28 should go evenly into 252. So let's kind of deal with that first. That seems to be the logical way to do with it. So if I just start out with 28, and if I double 28, I get 56. Okay, so that's just 28 times 2. And matter of fact, let me just go ahead and use the dot since we've got variables there. So this is just 28 times 2. All right, so I'm going to go ahead and double 56 and get 112. Well, if I double that, well, that's going to be equal to 28 times 4, or 2 times 28 times 2. All right, I'm going to double this again, and I'm going to get 224. So that's going to equal 28 times 8. And I'm not quite there. I need 252. I have 28. And if I add 28 to 224, I get 252. So that's got to equal 28 times 9. All right, so that means that this 28 over 252 can cancel or reduce down to 1 over 9. All right, a couple other things that I see going on up here. And so let's just kind of write this in so as I go on. I'm going to give myself lots and lots and lots of room here. So I'm going to have 28. Here I've got an x cubed. I've got a y to the fourth and a z to the negative 2 power. And again, I'm stretching these out and giving lots of room just so I can kind of show you what's going on. All right, so then down below I have 252. I have an x. I have a y to the negative third power. Whoops, a little bit of a glitch there. So this is going to be y to the negative third power. And then I have a z squared. And again, all of this is raised to the 3/2 power, which we'll take care of last. All right, so 28 over 252, we already know that this is going to reduce to 1 over 9. 1x is going to cancel out of the bottom, so this x here is going to cancel, and then this will be an x squared up top. This y to the negative third power, this is going to come up top as y cubed, and z to the negative 2 power is going to come down below as z squared. All right, so let's clean this up a little bit more. So my 1 I don't worry about because 1 times anything is just itself. So I'm going to have x squared. Y to the fourth times y cubed is y to the 7th power. And since that y cubed moved up top and this z cubed moved down below, I have z squared times z squared, which is z to the fourth. Don't forget about this 9 hanging out there. So I've got 9z to the fourth. And this is all over to the 3/2 power. All right, so it's looking a little bit better already. Okay, so now if I take a look, I've got x, y, and z, and so on and so forth. So my answer choices are getting a little bit better. All right, so when I have this x squared times a fractional power, this just becomes 2 times 3 divided by 2. And so that's the way it works with all of the variables. And I can already see kind of a problem here, and it looks like we've got a typo up above, but we'll address that in a minute. So let's just go ahead and work with this 9. So if I take 1/9, and again, I'm just going to separate this out of the rest of the problem, and I'm going to go ahead and make this to the 3/2 power. Okay, so remember, the over 2, the denominator of 2 is a square root. So the square root of 9 is 3. Okay, so again, this is going to be equal to the square root of 1/9 cubed. Well, the square root of 1/9 is 1/3. Because the square root of 1 is 1, the square root of 9 is 3. And so 1/3 cubed, well, 1 cubed is 1, and 3 cubed, 3 times 3 is 9, times 3 is 27. So this just becomes 1/9 to the 3/2 just becomes 1 over 27. Now to take care of the other variables, I just multiply out. So so here I'm going to have x to the 2 times 3 divided by 2, and this will be y to the 2 times 3 divided by 2. I've already taken care of my 1/9. This is going to be 27, and this will be z to, I'm sorry, to the y. It's not 2 times 3, it's 7 times 3, because we started out with y to the 7th. Let me fix that. All right, and then z to the 4th power, so this will be 4 times 3 divided by 2. All right, so again, I can see a problem with y. It looks like we have a typo. So it looks like one of these two y's was incorrect. Probably, it should have been a y to the 6th when I was done, not y to the 7th, but we'll get there in a minute. Okay, so x, 2 times 3 is 6. 6 divided by 2 is 3, so this gives me an x cubed. My problem with y is I have 21 over 2, so I really end up with y to the 21 over 2 power. And the problem is all of my answer choices have y to the 9th. So again, this really should not have been 21 over 2. It looks like it should have been 18 over 2. So if I have y to the 4th and y to the negative 3rd, my guess is this probably should have been y to the negative 2 power. But let's just work with what we have. All right, so we know we have 27 in the denominator, and then z, 4 times 3 is 12. 12 divided by 2 is 6, so this would be z to the 6th. All right, so looking at my answer choices, H looks like the best choice, but it's not really the correct answer. Again, it looks like we have a typo, but if you want to know how to do it, that is how we do it. But you can just see that the numbers didn't quite work out the way the answer choices are. But H looks like the best choice. However, I would probably talk to your teacher about this one because we have a problem with the numbers and what looks like a typo in one of these two exponents. Okay, so last problem here where we're looking at the area of a rectangle, which is a pretty typical problem. The one little twist that they probably threw in here was that we have an x minus 2 squared instead of just two binomials. That just means we're going to have a cubed in our answer. So if we just want to kind of play around with our answers a little bit, looks like, you know, F and H are going to be wrong. But let's just go ahead and work our way through this. Then I'll show you the Inspire solution as well. All right, so x minus 2 squared, when we're squaring a binomial, again, there's a little trick. It's the first, both terms get squared, so I'm going to have an x squared, and then I'm going to have a plus 4 at the end because x squared is x squared, and negative 2 squared is plus 4. I multiply this number here by 2, so negative 2 times 2 is negative 4, so my middle term is going to be minus 4x. All right, and then I still have to multiply this by my 3x minus 5. And so that's going to be what my answer is. Okay, so when we multiply this, we have a trinomial times a binomial. All that means is we just have to multiply everything by everything. So x squared by 3x, negative 4x times 3x, 4 times 3x. X squared times negative 5, negative 4x times negative 5, 4 times negative 5. So we just have to go in order, and we're going to be just fine. So x squared times 3x is just going to give me 3x cubed. Okay, now already if I have a 3x cubed, I can see here that I can probably jump to j. I do see a little issue with the answer. Again, kind of another one of these, but it looks like j is going to be the correct answer because we have a 3x cubed. But let's go ahead and finish out the multiplication just so you can see the whole process. All right, so that was x squared times 3x. Now let's go ahead and take negative 4x times 3x, which gives me negative 12x. And now we're going to take positive 4 times 3x. I'm sorry, that's negative 12x squared, negative 4x times 3x. And then I have 4 times 3x, which will be plus 12x. All right, so that's everything times 3x. Now let's take everything in the first trinomial times negative 5. X squared times negative 5 is minus 5x squared. Notice I'm stacking like terms on top of each other. Negative 4x times negative 5 will be plus 20x, and then positive 4 times negative 5 will be minus 20. And then let's go ahead and just do our addition here. So I get 3x cubed minus 17x squared plus 20, I'm sorry, not plus 20, let's try plus 32x and then minus 20. So again, if I take a look here, it looks like it should be j. The problem is the answer choice is missing an x, but it does look like it should be j. And just to verify my answer, you saw earlier how to store a number into the calculator. So again, if I check here at the calculator, I just store the number 3 into x, type my initial one, which is x minus 2 squared times 3x minus 5, and then I multiply it by my answer, and I get it true. So sure, it turns out that if I add an x here and make this 32x, that is the correct answer.